Hello, and welcome to this electronic seminar which will provide an introduction to a weight of evidence approach for food authenticity analysis. This presentation aims to disseminate guidance and best practice on implementing a weight of evidence approach and suggests when and where the approach should be adopted through the use of case studies. Over the course of this presentation, we will look at what a weight of evidence approach is and when you would use it. Once a weight of evidence approach has been considered appropriate, we'll look at what information is needed, how to assess it, and how to express the outcome. Finally, we'll look at a couple of case studies to help illustrate some of the points covered during the presentation. There is no accepted definition of weight of evidence. However, in general terms, it is considered a process for evaluating several pieces of evidence to come to a conclusion where a single piece of evidence is insufficient. This can be drawn together from two contexts: the likelihood of a single item of evidence being true and the gathering of multiple pieces of evidence together to reach a conclusion. In the context of food authenticity, then the multiple evidence approach is the norm. There are a number of scenarios where a weight of evidence analytical approach may be suitable. In the first instance, this will be where there is no applicable legal limit to what is being evaluated. As an example, this would be determining if the origin of a food is as stated. We will use this as an example to illustrate the relevant points to consider as we work through a case study addressing the issue of whether a sample of pork beat is of the origin stated. In the second instance, a weight of evidence approach may be applicable where the output of an analysis is reliant on metadata. This may be in the form of interrogating a database that has been populated with reference samples to establish whether the sample in question sits within the population or not. Taking the pork sample case study as an example, a stable isotope analysis may be undertaken. To evaluate the strength of the evidence from this, a number of factors may be considered, including how the database has been populated, e.g. type of sample, number of samples, origin of samples, how significant the variation from expected the result was, e.g. just outside of the population, a long way outside, just within. Thirdly, a weight of evidence approach may be considered where a number of pieces of evidence give conflicting conclusions. This could be analytical evidence highlights a discrepancy in the origin, however, records from the food business operator indicate the origin is as stated. Fourthly, where the analytical conclusion is based upon an individual's opinion, this would raise questions as to their expertise and experience with the matter in question, or simply whether they were telling the truth or not. And fifthly, where there has been a reliance on old or out-of-date data. Again, in the case of the pork sample, this may relate to data that is out of date, e.g. relates to traditional feeding practices as opposed to modern regimes. A weight of evidence analytical approach may be suitable in food authenticity evaluation when there is no single confirmatory test available or where a legal or other robust limit is not available to appraise the test result. Published guidance on gathering a weight of evidence for food authenticity assessment is currently lacking, with the exception of the publication of the Weight of Evidence Toolkit described here and the associated Defra publication, details for which are included in the reference section of this presentation. So, what is the process for adopting a weight of evidence approach? Firstly, and most importantly, is to define the problem that requires resolving. Prima facie, this may seem simple. However, as we will see in the next slides, it requires careful consideration. Once the problem has been defined, the process of gathering evidence is undertaken. This step can take some time and effort, as evidence from a multitude of sources may be required and may require specialist investigators. When the evidence has been gathered, the process of weighing and drawing conclusions can be done. There are many types of evidence used with food authenticity analysis, but these may be broadly divided into either analytical evidence or product traceability evidence. Analytical evidence may be thought of as the data produced from an analysis or assessment of a sample or subsample, and may be physical, chemical, biochemical, or microbiological in nature. Product traceability evidence is primarily derived from supply chain traceability information or data linked to this. Product traceability evidence can contain more detail, and this is further explained in the next slide. As a minimum, product traceability evidence will comprise a specific product description, batch codes, durability date codes, and production lot information. Basically, everything that would be needed to trace a product. Supply chains can comprise of different businesses, each fulfilling a different role. For example, agronomy, consolidation, importer, manufacturing, contract packing, agents, brokers, or transport and storage. So, information pertaining to any or all of these may be useful. In addition, who is responsible for the product at each stage in the chain is important to know, as a product may change hands or ownership several times without physically moving location or being handled by certain roles in the chain. The herringbone diagrams on the following slide provide a useful indication of the variety of the different types of evidence that may be available. The list of evidence examples provided on the previous slide is not exhaustive, and additional examples are indicated in the figures provided on this slide. So, what considerations are needed to define the problem that requires resolving? Whilst this may seem simple, some thought should be given to understanding exactly what the issue is. For example, if we take an origin of pork meat scenario, let's say the sample was marked as of British origin. This could lead to defining the problem in a number of ways. Is the pork British? Is the pork not British? What is the origin of the pork? Clearly the questions are similar, but they are not the same, particularly with respect to analysis and the weight that can be then applied to the data generated. Why is this? Well, if the commonly used technique of stable isotope analysis is applied to the sample, the metadata used as reference may only contain samples of limited origin. If the samples contained only GB origin reference samples, an answer to question 1 and question 2 may be possible. However, it would be beyond the capability of the model to provide an answer to question 3. Similarly, if a vegetable was described as organic, the questions may be, is this sample organic, or is this sample not organic? Again, it is easier to answer the is this sample not organic by a series of tests, whereas there is no test available to positively establish if a vegetable has been produced using an organic regime. Once the problem has been defined, the process of gathering evidence can be undertaken. It should be noted that with food authenticity issues, the issue will normally have arisen as the result of an adverse test report. This report will form part of the evidence. However, additional information should be sought to support or counter the initial findings. A detailed summary of the types of evidence that can be gathered are given in the Defra document, a toolkit to support weight of evidence approaches for food authenticity investigation. A link is provided at the end of the presentation. Once the evidence has been gathered, it is helpful to collate it into lines of similar types. This will enable a comparative assessment between evidence from different sources to be made or identify a weakness that could affect subsequent data produced from that line of investigation. All evidence should be critically challenged. Ask questions about the methodology used. Was it fit for purpose? Did the analyst or analysts conducting the work have sufficient skills and experience? If the output is based upon the opinion of an expert, do they have the requisite expertise? Was the initial question asked of them within their field? When looking at supply chain records, question whether dates in the chain tie up. Are handwritten records all in the same handwriting and pen type, particularly if they span a longer period of time? Are computerized records date and time stamped? Do they have an audit trail that would record any amendments? Try to support the principal pieces of evidence with supporting evidence, such as checking whether goods receipt records tie up with manufacturing records. Do laboratory information management system numbers for samples submitted at the same time or different times look realistic? Overall, question where the weaknesses in the data chain are, specifically with respect to the initial question asked. Let's look at some qualitative examples of different strengths of evidence. In the comparative scenario, two conflicting results may have been received from different test houses. One may have extensive experience of the analysis, hold specific UCAS accreditation, and can demonstrate a significant history of satisfactory external performance testing. The other may have generic accreditation, conduct similar tests but not the specific one in question, and has limited or an out-of-date history in external performance testing for the test. Clearly, the significance or weight given to the first result will be greater than that of the second. Consideration must also be given for how some evidence may weaken or strengthen other evidence. So, for example, should a weakness be identified in the taking of the sample, e.g. it was not representative of the sampled lot, this would significantly weaken any data produced from analysis of that sample, no matter how robust the analysis was. But how do we get a more quantitative assessment of the data? An in-depth tutorial on quantitative weight of evidence approaches would be extensive and beyond the scope of this presentation. However, we will briefly touch on one approach, this being the use of likelihood ratios. The basis of this approach is to consider the ratio of the likelihood that two competing propositions are true. This ratio can then be used to describe, in verbal terms, the relative strength of the propositions against each other. This would range where the likelihood ratio is between 1 and 10 as slight or weak support to very strong support where the likelihood ratio is greater than 10,000. To demonstrate, we'll consider the scenario of a consignment of pork designated as being of British origin. In this instance, we would define the propositions as 1. The sample is British as described on the product label, or 2. The sample is not British contrary to the label description. So, taking the two propositions and using the individual pieces of data, a probability for each can be estimated. For example, the SERMS may be a borderline result, and therefore the probability that the sample is within model, proposition 1, may be estimated at 0.55, always expressed as a fraction of 1, and the probability that the sample is outside of model, proposition 2, is 0.40. The likelihood ratio is calculated as the ratio of the two probabilities, in this case 0.55, divided by 0.40, giving a result of 1.4, rounded. A standard scale can then be used to describe how likely the first proposition is supported against the second. In this instance, there's a very weak support for the proposition. Taking the supply chain data, it might be that there are no records, goods inwards or financial transactions that relate to the purchase of the pigs for slaughter. The probabilities may then be assessed as the pigs were purchased through illicit means, proposition 2, 0.95 against the pigs were purchased through legitimate means, proposition 1, 0.005 giving a likelihood ratio of 1,900, this being reported as strong support that proposition 2 is likely versus proposition 1. The examples given here are simplistic, and there are some cautions that should be applied when adopting a likelihood ratio approach. Further details and guidance on evaluative reporting can be found through the links at the end of the presentation. On the next slide, we will look at a case study involving a pork joint sample. To provide some additional insight into the process of undertaking a weight of evidence evaluation, we will now work through a couple of case studies for food authenticity. Case study 1 involves a consignment of pork joint samples with a place of origin labelling inconsistency. If we first consider the background to this case, then we see it involves a consignment of pre-packed pork shoulder joints which have been sampled at a retail level and analysed for country of origin using stable isotope ratio analysis. The analysis undertaken returned results which suggested that the test data for several of the samples were inconsistent with the declared place of origin, and so further investigative work was warranted. The question being asked in this instance being, was the consignment of pork shoulder joints of British origin and as indicated on the label? In terms of the analysis undertaken, stable isotope ratio analysis is considered the current standard method to determine the place of origin of a sample. For the case in question, the analysis had been undertaken by ISO 17025 accredited laboratory, with 20 samples being submitted for analysis. The results from 7 samples were reported as being not consistent with British origin, 12 as being consistent with British origin, and 1 reported as inconclusive. However, the technique is not considered to be conclusive when used in isolation for origin identification, and further investigation of the case was therefore advocated. So, starting with the analytical evidence, we know that the samples were taken, transported, and stored according to the requirements for official control samples, that the stable isotope ratio analysis is an accepted technique for use in the determination of geographical origin, and that its limitations are well known, principally revolving around the reference database employed. We know that the last laboratory was ISO 17025 accredited and had participated in rounds of proficiency testing with acceptable results, and that all the required quality checks had been employed and were satisfactory. The staff conducting the analysis were experienced and competent in undertaking the method. However, and of critical importance was that the database employed only contained 400 British samples, with none from outside of GB. Based on the results of the analysis undertaken and the inconclusive results obtained, a weight of evidence approach was advocated, including a product traceability exercise for the samples indicated as inconsistent with the British origin. If we expand the information to include traceability records, then we can see that the products were sold at retail level from an independent butcher who owned a number of shops, that the butcher used 2 local abattoirs, with all the joints in question coming from just one of those. The respective sales and invoice records indicated the highest livestock intake dates, details for which were examined. This information confirmed that all of the animals used were supplied from across the UK, and that no animals from outside the UK had been received during the relevant dates. Further cross-checks between intake and animals slaughtered showed no discrepancies in the information provided. Therefore, it was concluded that the analytical evidence could only be considered indicative, and that the operator records revealed no evidence for non-GB animals entering the supply chain. In this instance, the traceability evidence was considered to outweigh the analytical evidence and that the pork was of GB origin and compliant with the labelling regulations. For the second case study, we shall examine the authenticity of a shipment of wine will be considered. In terms of the background detail, we can see that a number of wine samples, labelled as Italian, were taken at a small retailer as part of a routine inspection and suspected of being counterfeit. The samples were sent for analysis with the results indicating the wine as being non-compliant and hence further investigative work warranted. In this instance, the question being asked was, were the bottles of wine sampled of Italian origin as indicated on the label? An initial analysis undertaken, with the samples being sent to an ISO 17025 accredited laboratory for alcohol analysis for compliance with that declared. In addition, wine compositional profiling was undertaken using proton nuclear magnetic resonance 1H-NMR, employing both univariate and multivariate analysis. Discrepancies in the sample's 1H-NMR profiles indicated the presence of added water and off-model anomalies, suggestive of these samples not being genuine. Targeted tests undertaken to confirm the NMR profiling results confirmed the findings, warranting further investigation. Samples for analysis were taken in line with legislation and code of practice and transported and stored according to the requirements for official control samples. 1H-NMR wine profiling was undertaken, which is a recognized technique for use in the determination of wine authenticity and was performed on the samples by an ISO 17025 accredited laboratory by staff experienced in conducting the analysis and interpreting the results. NMR profiling metadata generated for wine profiling by the analytical laboratory was regularly challenged with genuine and known false samples, the outcomes of which were satisfactory and documented. Based on the results obtained for 1H NMR analysis and the non-compliant results obtained, a weight of evidence approach was advocated, inclusive of a product traceability exercise for samples indicated inconsistent with an Italian origin. If we consider the available traceability records, we can see that the wine was sold at a small retail outlet, the owner of which, on request to provide the relevant records, indicated they were not available. As the bottles were marked with the name and address of the producer in Italy, recorded delivery letters were sent to the marked address, requesting relevant information on the origin of the wines. These letters were returned by the Italian Postal Service as no such address. Overall, taking into consideration that the non-targeted analytical methods indicated sample compositional discrepancies when compared with wine of the types and geographical origin stated on the sample label, and that no supporting documentation could be produced by the retailer to support the product being genuine, with the name and address of the wine producer being found to be false, then the samples, on the evidence considered, were concluded to be illicit. In summary, weight of evidence can be a useful technique in the investigation of food authenticity issues and can be used both as a qualitative and quantitative tool. Critical assessment of evidence against a well-defined question is essential, as is clearly documenting thought processes and outcomes. The following resources are provided for further reading into the use of a weight of evidence approach in food authenticity and the use of likelihood ratios and evaluative reporting in data assessment. This eSeminar has been produced as part of the Joint Knowledge Transfer Framework for Food Standards and Food Safety Analysis, and which is funded by the Department for Environment, Food and Rural Affairs, the Government Chemist Programme for 2020 to 2023, the Department for Business, Energy and Industrial Strategy, the Food Standards Agency, and Food Standards Scotland.